Okay, Godot users, I want to take a little time to show you a second way of adding animation to something you've created in your game. So I showed you how to use Animation Player, but here I'm going to use a slightly different technique that you might actually think is easier. It's a little less flexible than Animation Player, but if you're just simply trying to create a very simple animated sprite, this might be the way to go. So I'm going to create a new scene. And this object actually is not super important that it interacts with other physics bodies. So instead of a kinematic body, I'm going to try to do something a little bit different, and I'm going to use an area 2D. An area 2D can still take or detect collisions, but it won't be stopped by those collisions necessarily. And it works similarly, but also a little bit differently as well. So I'm going to create this as a snail. And so my snail is going to have not a sprite, but this time I'm actually going to do an animated sprite. So you can see that I've practiced with this, but if you can't find it in your list, go animated sprite. And so that's going to be a child of snail. And then you'll see there's all kinds of different warnings over here. So my area, despite the fact that it's not a kinematic body or a physics body, still wants to know where its collision area is. And then the animated sprite is looking for something called frames. So with my animated sprite, I'm going to come over here where it says my frames is empty. And I'm going to say new sprite frames. When I click on that, a whole new window appears at the bottom. So I am going to go to my PNG folder that I created in the last video. And you can see that I've created a subfolder, and it has 4 separate PNGs. So unlike the last example where I had all of my PNGs as part of a strip, I have them separate. And the flexibility that that allows is that I can drag them in one at a time and have all of my frames oops, I almost grabbed the wrong one, be presented this way. Now you'll notice that they're very blurry and some of my pixel crispness isn't visible. Do you remember how to fix that? I'm going to give you a second to try to remember, and then I'm going to show you the solution. So if you don't remember, this blurriness is because Godot by default likes to filter its sprites. Works great for 3D graphics, but when you're doing a lot of detail with pixels, it's not ideal. So I'm going to select all of my snail PNGs. I'm going to come up here to import. I'm going to select preset and then 2D pixel. Once I do that, if I re-import, you will notice that it's all of my pixels and details are much more clear. Okay, so my PNGs are imported correctly. Let's see this in action. So to get this to play, I'm going to come over to the inspector, and this is my animated sprite node, and I can click on, I'm going to zoom in. This is actually a 32 by 32. This is not going to be a major character in my game. I can just simply click on playing, and my animation will play at whatever speed, frames per second, I have indicated down here. You'll also notice that looping is on by default. If I turn that off, then once it's played through, it would stop. But this is another way of having an animated sprite. Now, if I wanted this character to move or be able to collide, I would come up here and to the area 2D. I would again want to determine what it is. In this case, it's a moving object. I do want it to be able to interact with walls. So I'm going to leave those layers and masks selected. I do need to add as a child node collision shape and give it a collision shape. In this case, I think I'm going to go with rectangle and manipulate these grabbers until I am satisfied with how that looks. So I think I just need to go up a little bit higher. And you can play around with this for a long time and agonize over it, but for the sake of this video, I'm going to stop right there. I don't want to accidentally select my snail children, so I'm going to go and click on this to make the children unselectable. Now, it's not going to move, and so if I add a script, so you'll see it doesn't extend kinematic body 2D, it extends an area 2D. So my plan is just to quickly walk through how you get something that's not a kinematic body to move and do similar things to our kinematic body. So it needs a speed, so a snail is gonna move pretty slow. It's gonna need a direction, and my snail happens to be moving or facing the left, so I'm gonna have him move in that direction for starters. And let's see, what else do I need? For now, I think that's okay. In this case, because it's not a physics body, I'm gonna go ahead and do my programming in the process function. And what I'm gonna do is I'm gonna calculate velocity like I have. Velocity equals speed times direction normalized. This is all familiar to you. My snail will not move diagonally, but just in case I want to copy and paste this for another area 2D down the road, I'll add that. I'm going to say, if I try to use move and slide though, I'm going to get an error. And move and slide is not a valid, actually, I don't think that's why I'm getting an error now. But if I try to use move and slide in the game or run the scene, it's going to give me an error because move and slide is not a function or feature of an area 2D. So instead, I'm going to say position plus equals velocity. And what's going to happen is this is going to update as fast as a computer can possibly run this code, which is going to be far too fast for my snail. But maybe for demonstration purposes, I'll show you this. So I'm going to say save scene as snail. And let me put one in the room just so you can see the effect that this is going to have. So I'm going to add an instance of my snail. I'm going to drag him down here. And let's see how he moves. Now, he doesn't have to be on the floor. He doesn't have gravity. He's not going to be affected by any physics. But hopefully you'll be able to see this because this snail is going to be hauling some serious snail tail. So let's see if we can run the game and see if you can even see it. So that snail is moving real quickly. And the reason is because this updating of the position is happening again as fast as the computer can process the code. So I want to sort of even that out with so if somebody with a ultra computer versus somebody who's using a computer from 5 years ago, this snail his movement will be normalized. It will be equal on a computer regardless of its ability to run the code. And so I'm going to times that by delta. And delta is the time that in between frames. So it's going to be different for a mega computer versus a potato, which is, I guess, the internet slang for a really bad computer. So when I do that and we run the code, you can see that my snail moves much slower, much more like you'd expect a snail to move. Now, eventually, he is going to come in collision. And what we're going to want to do for that is we're going to want to use a signal specific to area bodies. Well, I think you'll probably see this in some other nodes as well. And that is, so I'll go back to our snail scene, when something enters it. And for our case, he's most likely to enter one of the physics bodies, and in particular, the static body. So when a body enters, is the same as colliding with a solid object, I guess, if we were comparing this to GameMaker. And I'm going to connect that to the code in the snail. And so when he collides with a body, in this case, most likely a static body, because remember, we said that he was a moving object that could only collide with walls, then we're going to have him do something similar to what we did with our fish. So if so the body is actually going to return whatever the object was. So we could say if body is static body 2D, so that means we're checking to see if this collision is in fact with something that's a static body 2D, then we can say direction times equals -1. So we've seen that before. And then we're going to say if direction is greater than 0, which means he's moving to the right, then we'll set flip H to true because he's facing the left by default, else flip H equals false. Now, because our snail is moving so slow, if I was to try and oh, I made a mistake. It's not the area 2D doesn't have a flip H property. It's sprite. I always make that mistake. So let me fix that. So get node sprite, flip H equals false. And so to sort of speed him along, sort of like when you see a snapping turtle on the road, we're going to help him along here. We're going to grab that snail and we're going to move him closer to the wall. Again, it's not super important that he touches it. In fact, we don't want him to touch by default because then that will, he'll just jerk back and forth because he'll always be in collision. So let's see if this works. Well, let's see if our slow moving snail collides with the wall. And he does, and it crashes. That's because I did not do direction.x. So it was looking for a vector 2, and I only provided it with a single integer, and that wasn't going to work. So bad coding on my part. So he's going to collide with that wall, and it, let's see, flip H. Oh, because this is really bad. So before, when we did the kinematic body, the node we had to get was in fact called sprite. In this case, it's animated sprite. Animated sprite, and it has to appear exactly as it does here. Animated sprite. Let's see. Animated sprite. Let's try that one more time. And then if it crashes again, I'll stop the video so you don't have to watch this painful process. But in this case, it worked exactly as we hoped. So we have an animation. We have an area 2D that is capable of detecting collisions and changing directions. So just a little thing now with this, I could put some snails upside down, for example. So go back to my game. I'm going to... actually, this may have some unintended consequences here. I'm gonna, so this would only work if I want to flip it horizontally. I'd have to add some more checks if I wanted some snails to crawl up the wall. And maybe that's something I can do off camera, but I'm gonna Control D. That's the wrong one. Control D, bring this up here. Now in this case, my snail is facing the wrong direction. So I could go into the snail, go into this transform, we'll rotate him 180 degrees and drag him down just so he's barely not in collision with the wall. That shouldn't have affected my other snail. All right, so let's give that a try. So now we have two snails doing their thing. And unfortunately, because of the way I have done this, he is facing the wrong direction. So it won't quite work that way. I'll have to do some thinking about how to make it work depending on how he's. So for now, I'm going to get rid of him and consider how we can make it so that he can be on different surfaces as well. But that's going to do it for this video. We used an area 2D as our base node for a character. We used an animated sprite versus the animation player. And I think sometimes this is a little bit easier because then if I wanted to rearrange the order of this, it's much easier to just grab one and move it. And changing the frames per second and having control over that is a lot easier. And then we used a signal to detect when it was coming in collision with a static body. And we used some new code where we determined what exactly it was we were in collision with. So lots of stuff. Hopefully you learned something in this video and have one more tool in your tool chest for building games. Thanks for watching.